Okay, so we're going to be asked to find the volume of a solid based on the graph that we're given. And so we're given that f of x is equal to the square root of x, and g of x is equal to 6 minus x. And so as a quick reference to graph it, we know that square root of x is like that, and 6 minus x is going to look something along the lines of that. And that it's bounded by the x-axis. So keeping that in mind, we can draw the large version, I guess. And so we get the square root of x is just like that, and g of x is going to be like this. And don't forget that we need to label these. And by plugging it into the calculator, we can realize that the intersection is at 4, 2. That's 4, that's 2. And the g of x crosses the x-axis at 6. We see that by plugging it into the calculator and such. And so we find out that this is our region T. So, aside from that, now that we have our region T, they tell us that T is the base of a solid, and it is the base of an equilateral triangle. So this is the base of an equilateral triangle. Yay! And so we know that to find the area of an equilateral triangle, we're going to need the square root of 3 over 4, and that'll come in handy just a little bit later. And so, back over here, we're going to find the volume of the solid, and so to find the volume of the solid, we're going to need the base, and base is always equal to top minus bottom. And quickly, as a reference to the graph, we see that at the intersection, the top changes. So that means we're going to need to have two integrals. And so we're going to need to have two integrals that will change at x equals 4. And then the area is going to be the square root of 3 over 4, because that's how you find the base for the equilateral triangle, times the base squared. So with that in mind, and our two integrals, we can go ahead and just draw the two graphs so that we'll be able to model our integrals off of. So we get that, and that. That's little. It's too little, so we're going to have to redo that. That and that, we get to do it. And once again, that's still at 4, 2. And so this will be our first integral. We'll call this 1. And this is still f of x, and this is still g of x. And the other one, I'll draw the same thing. 4, 2. Still f of x, and g of x. And this will be our second integral. And we'll call this 2. Okay, so we are now ready to set up our integrals. Yay! So the volume is equal to the integral. And the first one we see, it starts at 0 and it ends at 4. That's where f of x is still on top. So we'll go from 0 to 4. And then we'll just straight take this formula and plug it straight over here, and we'll get square root of 3 over 4 is the base, and we know that the base is top minus bottom, and so the top over here is f of x, and f of x is the square root of 3, minus the bottom, and the bottom is the x-axis, so that's just going to be 0. So we don't need to plug in 0, and we'll square that, and don't forget to add in dx, since we are taking the integral, and we'll add it to the second integral, which goes from 4 to 6. 4 to 6. And we'll again take the same formatting from over here. Square root of 3 over 4. And this time, g of x is on top. And since g of x is 6 minus x, we'll need to... I don't know why I added that extra set of parentheses. And then we'll square that. And once again, don't forget to add in your dx. Now that we're done writing our integral, you could try to solve it by hand maybe, but that's not really fun and something that I'm interested in. So we're just going to use the Math9 function on the calculator. So if you have the new updated version, you just plug in exactly as how you wrote it, but I have the older version, so it'll just take a little bit more typing and memorization. So for the first part, you just write in your formula, like what's being integrated. And that's square root of 3 divided by 4 times, actually we're going to put that in parentheses, square root of 3 divided by 4 times square root of x squared, and then you put in your variable, which is x, and a to b, so 0 to 4, and you get that that is equal to 3.4641102 plus, and then you go ahead and do your second integral, 9 square root of 3 divided by 4, and then you multiply that by 6 minus x squared, and don't forget your x, and then 4 to 6, and you get 1.1547701. You just want to go to like 5 decimal places out so that you get a correct answer at the end. So we did everything else, and we get to the easiest part where you just add the two numbers together, you plug them in your little calculator, and then you get that the volume of the solid is equal to 4.6188.